So here we're just creating a new V box, which is short for vertical box, aligning it to the center. I'm going to set the preferred height to 600 and width to, I think I set it to 400. We'll drag an anchor pane into the V box, and then we'll drag a text field into the anchor pane. We'll also add a separator into our V box to separate the sections. We'll set the vgrow attribute of the anchor pane to always. And then here we'll set preferred width to 200 and everything else to use computed size. We'll add a prompt text to the text field to let us know that it's the history of the expressions that we typed in. We can disable focus traversable so they can't click it or tab into it. And here we can just set all the constraints to 0 for the text field. We'll set a preferred width and height and leave everything else computed. And this is where we'll assign an FX ID to the text field. And this is so that we can call it from our code. This is so the variable has a name. We'll put another anchor pane inside of our VBox, and then we'll put a text field inside that anchor pane, and this is going to be for our input. We'll add another separator here. Set all this stuff for our anchor pane here, all these attributes. And then we're going to click on the text field over on the left pane and set the attributes on the right. You can set them however you want, or you can do what I'm doing here. It doesn't matter. Go to the layout pane and we'll set its constraints to 0 on all 4 sides. And set the height and width. And then we're going to give it an FX ID because it's going to be our input text field. Drag in another anchor pane for the bottom section. We'll add one last separator beneath that anchor pane, and then we'll add a button bar with 3 buttons to that anchor pane. Those 3 buttons will be for clear, clear all, and backspace. Again, just aligning the text in the button here. And you can pretty much just repeat this process for these 3 buttons. Don't forget to give them FX IDs because we can set them to clear the fields and backspace and so on. I didn't actually do that for this video, but it'll be easy for you to do it if you just put the FX IDs in now. And now we'll add one last anchor pane underneath that last separator that we just created, and we'll put a grid pane inside that anchor pane. This is going to be for our buttons. Here we can right-click on the grid and add columns and rows. We want to make our grid 4x5 to represent our numbers and operators. Here I'm just setting the properties for the anchor pane holding the grid pane. We'll set the constraints of the grid pane to all 0 so that it fits into our anchor pane here. So what we're going to do is add an anchor pane inside each one of these elements of the grid pane, and then we're going to add a button inside each one of those anchor panes. And that's going to be for the buttons in our calculator. So basically what I'm going to do here is show the first few of them at this speed now, and then I'll just, speed it up for the rest of them because it's really just a repeating of the process. The only thing you have to keep in mind is to give each one of the buttons an FX ID so that you can call it from the code. Because without an FX ID, it's not going to be able to be called from the code when we actually write the code to make our calculator. So just remember to do that. And you'll see me do that in these steps here. So just watch. We're also going to assign a method that gets called anytime one of these buttons is clicked. So we're going to assign one of those methods for each one of these buttons. So for example, button 0 will be button 0 clicked, button left parentheses will be button left paren clicked, whatever, so on and so forth. And basically just repeat this process for all the buttons, and you can arrange it however way you want. It doesn't really matter. Just remember to assign everything FX IDs and a method. I'm going to paste some buttons in because I have it from the project that I previously made of this. And when it's all done, it should look something like this. I decided to make the equals button blue, but you don't have to do that. But I'm showing you here how I did it and just changed the FX background color. Right, so now comes the fun part where we open up IntelliJ and create a new project. So let's do that now. We'll call it calculator. You can call it whatever you want. I actually don't know if we need these libraries or not, but we're going to add them anyway. And here's our project that it generates for us by default. We're going to be changing this hello view fxml in a moment. We're going to go to the controller tab here on the left, and we're going to assign a controller class. We'll call it calculator controller. And now that we've done that, we can save it, and we're going to save it as calculator view, not calculator controller. I mistakenly save it here as calculator controller, but it's supposed to be calculator view.fxml. We can delete hello view.fxml. We don't need it. Just adding it to GitHub here. You can if you want, if you made a GitHub at the beginning, but you don't have to. You should, but you don't have to. We can delete hello controller. We don't need this either. And what we're doing here is known as the MVC design pattern, stands for Model View Controller. What that does is that separates the model, which is going to be our stacks, queues, from the actual UI where the user is inputting data. So basically, they only interact through the controller class, essentially. The controller acts as an interface between the UI and the backend. And here I'm renaming calculator controller to calculator view. You always want to refactor when you rename a file or a variable or anything like that. You never ever want to just rename it. Here's the fxml file. And now in SceneBuilder, we can go to view and click on show sample controller skeleton, and then that'll generate the skeleton code that we can now paste into our controller class. And here first we'll rename the default hello application to main. We'll create our calculator controller class. And then we'll just paste that right in here, and here it is. Just when you paste it, make sure you have the package up at the top. Here I just condense a lot of the variables into a short list instead of one big vertical list, but you don't have to do this if you don't want to. It just shortens the code. Okay, so now that we've built the UI and connected it to IntelliJ, let's run and see if we at least get the UI to show up. If you get this error, don't panic. We're going to fix it right now. Here we go. You want to make sure that this FX controller here not only matches the name, but matches the package path. So here we have it in com.southpaw.calculator. So I'm going to just update the path here to make sure that it matches properly. This way it's connected. And now we can go into our module-info.java file and just update the opens and exports to make sure that we're exporting and opening the proper files here. All right, so now let's hit run one more time and see what we get. Alrighty, we're ready to start. So the first thing we're going to do is create our stack class. This stack class can hold any type of object, so we're going to set it to E instead of a specific type like string or int or whatever. And it's going to be an array-based stack with an integer representing the top of the stack and an integer representing the capacity. And here we'll write the constructor, which sets those values when a stack is created. We'll set capacity to 100 because that's way bigger than it's going to be anyway, so it's big enough. We'll cast data to an E type of array so that at runtime it knows that it can be any type. And we go with object because it's the most, that's the highest level of the object hierarchy. Everything is an object in Java. And we'll set that array size to capacity and top to -1 for a brand new stack. Java's going to yell at us for an unchecked exception, but we can just bypass it, also known as suppressing. We'll write a Boolean method called isEmpty that just returns whether or not the stack is empty. And right here, I'm going to show you how you can condense this if-else condition to just one line. And now we'll create another method called isFull to check if the stack has reached its capacity. A method called getSize that just tells us the number of items on the stack. Now we'll write a method called peek, which just shows us the top element of the stack. Doesn't do anything to it, it doesn't remove it, doesn't modify it anyway. It just returns it to us, tells us what it is. It looks at it, basically. Optional Java doc comment. Now we'll write the push method, which just allows us to add an element to the top of the stack. If it's full, we throw an exception. If not, we increment top by 1 and set data at the top element to the element that we're adding into the stack, to the top of the stack. And here I'm just showing how you can separate it into two separate lines or condense it. And now we add the pop method, which returns and removes the top element of the stack. So it removes the top element and then it decrements the size of the stack by 1. And now we can go ahead and create our linked list class, which is going to be the underlying structure for the queue we're going to make. So the way a linked list works is it's comprised of nodes. So we're going to create an inner class called node, and each node has a pointer in it to the address of the next node. So basically each node can go directly to the next node, but that's it. It can't, you have to traverse it that way. So that's the way a linked list works. So now that we created that node constructor, we're going to add a couple of private variables or class variables to the list itself. We have the head, the tail, and the size, which will be an integer. Obviously, head and tail are both nodes. We don't need a constructor for the linked list. And similarly to our stack, we can make a method called isEmpty to check if the list is empty. And again, we'll make a method called getSize that just returns the size of the list or the number of elements in the list, which is just represented by our size integer. And then we'll have a method called addLast, which just adds to the end of the linked list. And it, of course, uses the isEmpty method to check, because if it is empty and we're adding one element to the list, we want head and tail to be the same element at that point, since there's only one in the list and it's the only one, so head and tail are the same, obviously. In either case, whether it's empty or not, we're going to create a new node. Then in the case where it's not empty, we're going to set tail's next value to the node being added and tail to the node being added. Then we increment size by 1, and here I'm just condensing the code. And then we'll add a method addFirst, which just does the opposite of addLast, obviously, and you'll see that in the code logic here. Now, we could add an addAtPosition method if we wanted to, but we don't need to. You can if you want, though, if you want to have a challenge for yourself. And now we're actually going to condense these two methods, addLast and addFirst, a little more. So you'll notice that there's duplicate code here. So we're going to create another private method here called addToEmptyList, because in both those methods, the list can be empty. So we can just create a separate method here to trim the code a little bit. You don't have to do this, but you can if you want. And it keeps it a little bit neater and shorter. And then we'll create our removeFirst method, which just lets us remove the first element in the list, the element at head. And our linked list class is done. Now let's create our queue. This is going to be really, really easy since we already made our linked list, and the queue basically just uses the linked list to simulate the queue. So NQ just adds to the end of the queue, just like a queue in real life. Somebody comes onto the line, they go to the back. So we just call the add last method from the linked list. DQ is just the exact opposite, where we remove from the front of the list, and we don't pass a parameter the way we did with NQ, because we're not giving it any data, we're just removing. And we need an isEmpty. Now comes the fun part. So this is the controller skeleton that we pasted in a little while ago. And the method that gets called when we click our equals button is where we're going to do our operation. So this method is basically going to call the other methods that we're about to create. And it's going to call them in the order that it uses them, obviously. So we're going to start by putting it all into a try catch because it's going to be happening at runtime. So we should have it in a try catch. So we'll say if the input field is empty, we'll just do nothing, so return. And we'll just really quickly write out the exception and what it does when it comes across one, which is basically just print the exception. So the first thing we're going to have to do is what's known as tokenizing the expression, because the calculator itself only has a string as the input. You know, the input field, it just takes a string. So we need to take that string and break it up into smaller pieces, individual pieces, and identify what is a number and what is an operator. So that's what we're going to do first. We tokenize the expression, and then we start doing the evaluation. So let's make the tokenize expression method, which is going to return a queue of strings, because that's what we want it to do. We want it to put the expression into a queue of strings, the expression being a parameter that was passed to the method. Now this string builder called number builder here is just what we're going to use to build out a number. So if we come across a number and then we don't come across white space, or we come across a number and we come across a decimal point, it'll build up the number for us. So let's say we get like 11.4 or something, it'll know, because it doesn't come across any white space between 1 and the end of 4, that it's one number. So then it just appends it instead of creating a new number. Of course, C is what's representing the current character in the expression. Otherwise, if C is not a digit or a decimal point, we want to check if the number builder is empty. And if it's not empty, we're going to append the current number builder to the queue. And then we'll clear the number builder by setting it to a length of 0. Then we'll check to see if C is an operator. And if it is, we'll enqueue it. We'll have to use the value of method in the string class to convert the char to a string. Once we're out of the loop, we check again to see if number builder is empty or not. And if it's not, we'll just enqueue, because that takes care of the last item. And then finally, we'll just return that queue. And like we said a moment ago, the button equals click method is where this method's going to be called. So we're going to put that there first, because now that we've created the tokenized expression method, we can call it. And now the next thing we need to do is translate the expression from an infix, which is the way you normally see an expression, like a plus b, a times b, to a postfix, which is where the operator goes after the two operands that it's doing the operation on. So a plus b would be a b plus, for example. So we'll create a couple of helper methods, and the first one's going to be isNumber, which just checks to see if the current token that it's looking at is a number, in fact. So basically what this does is it uses the parse double method from the double class, from Java's double class, the wrapper class. And if it is a double, it'll return true. And if not, it'll just catch the exception and return a false. And now we're going to create a method called precedence of that returns a number based on the precedence of the operator that it sees. And we'll explain this a little bit more in a bit. And now we'll create a method called apply operator that actually applies the operation between the two operands. And also just remember to handle the divide by 0 exception. And we can add a default in case it comes across an unknown operator. So the next thing we're going to do is create a method called infix to postfix, and it's going to return a queue of strings, but it's also going to take a queue of strings as a parameter, and that queue of strings, when we call this method, is going to be what the tokenized expression returns, because tokenized expression returns a queue of strings, and that's going to be our expression in tokenized form, just a queue of strings. So we're going to be passing that return value to infix to postfix. And what infix to postfix is going to do is it's going to modify it using a stack and return the modified queue as a postfix queue. And that's what output queue here is going to be. So while infix queue has stuff in it, we're going to dequeue from it. And if what we dequeue from it is a number, we're going to enqueue it into our output queue. Otherwise, if it's an open parentheses, meaning it's an operator, of course, we push it onto the stack. So as you may be noticing here, it's operands in the queue and operators on the stack. And what this is going to do is ensure that no matter what, all of the operations are done in the proper order. If we get a close parentheses, we need to do some checks. If there's an operator on the top of the stack and it's not an open parentheses, pop that element from the stack and put it in our output queue. Now it's part of our postfix expression. You'll notice that we're actually not putting the parentheses in our queue, and this is because we can eliminate the parentheses once we come across a matching closing parentheses if we've already had a matching opening parentheses. If the operator stack is empty, we'll throw an exception with a message saying that the parentheses are mismatched. So this while condition looks like a lot, but all it's saying is while the operator on the stack has the same or greater precedence than the current token, which we now know is not an operand or parentheses because of the previous if-elses, pop it and enqueue it to our output queue. Finally, once we're out of that inner while loop, we'll push the token onto the stack. We pop whatever's remaining from the stack and put it into our output queue, and if we come across any parentheses, we know we throw an exception. And finally, we just return our output queue, which is just our expression in postfix form. And now finally, we can go down to our button equals click method and call the method that we just created, passing it infix queue as a parameter. We'll create a variable called postfix queue and set it to its return value. And then below that, that's where we're going to be evaluating the postfix expression with our next method. So we'll create a double called result to store that once we're done. And here we'll create our evaluate postfix method. So here we're creating a stack, a local variable stack. And while there's anything in the postfix queue we pass as a parameter, we're going to create a string and we're going to dequeue from it. And if the thing we dequeued from it is a number, we're going to push it onto the stack as a double. Then we're going to create two doubles, B and A. They're going to represent the two elements we're popping from the stack right now. We're going to call the apply operator method and store its result in a double called result. And then we're going to just push the result to the stack and return the top of that stack. And here we're just storing the result. We're calling evaluate postfix and putting its result in double result. And you'll notice that there's a couple of lines under there, text field input.setText and all that below it. That's just stuff that I added to clear the input field and also set the history once you enter your expression. So let's run it and see what we get. Drum roll. All right, looks good so far. Now you may have noticed two things. The modulo operator we didn't add any functionality for, and also if you try to use parentheses as multiplication, that won't work either. But those are things you can add if you want. Feel free to do that. I am not going to do that because I just spent a lot of time editing this video and I don't feel like doing it, and this calculator is not exactly not exactly a scientific calculator. So have at it. One thing we should do, though, is make the buttons on the actual calculator work because, we should do that. So for 0, we're just going to add this in here to, so that it doesn't append zeros, basically, and just keeps it clear if you keep trying to add zeros to an empty field. And then just add this line for the rest of the buttons. Just change the value in there, the char value after the plus sign. And yeah, just do that for all those and you're all good. Congratulations, you made a calculator using stacks and queues. Please don't forget to like and subscribe if you enjoyed the video and leave something in the comments. So, if you have any questions, I'll answer them. And yeah, thanks for sticking around. Hope you enjoyed the video.